Hi, everybody, and welcome to this Cloud Academy webinar about Amazon Rekognition. I am Alex Casalboni, and today I will show you what you can do and what you cannot do with Amazon Rekognition. And I will show you some examples about each feature offered by the API. And I will also share with you some code so that you can start using the API by yourself, and so on. So just in case it's your first webinar, just a little bit about what I do. I'm Alex, I'm from Italy, and I joined Cloud Academy in the early days, and I've been working on software and web development for 6 or 7 years. And I also do have a little bit of machine learning and image processing and multimedia processing background. So I'm more than happy. I'll be more than happy to share with you and to answer to your questions at the end of this webinar. Also, the webinar is recorded, so you can always rewatch it afterwards, and we'll send you a YouTube link, so don't worry about that. Okay, let's start. So what are we talking about? We are dealing with image analysis. Okay, it means many things, and today I'll explain you what this means in the context of Amazon Rekognition. So we can do mostly two things with Amazon Rekognition. First of all, we can do object detection. So objects or scenes or labels detection basically means that we want to analyze the image and extract a series, let's say a set of concepts or labels that represent that image. So we call it object detection, but it doesn't really mean that we look for objects. It's more about pattern recognition. So you may recognize a beach, a bedroom, a group of people. And there are many techniques, mostly based on deep learning and neural networks, as we will see, that allow you to extract labels. And this is very useful for tagging, for example, your images. Usually every label or tag comes with a confidence measure. So you can say, in this image, I can see, I don't know, a group of people, or a beach or a city view with, I don't know, 95% confidence. So this will help you to understand. You can set thresholds. You can more or less understand what's in an image with a kind of a confidence level. So you don't just have a set of labels or strings. And the second thing we can do is face analysis. So Amazon Rekognition allows you to do 3 different things for facial analysis. One is face detection, one is face comparison, and the last one is face indexing and search. So you index faces and then you search on such a collection of faces. I would like to, first of all, highlight what is not supported, at least yet, by Amazon Rekognition. First of all, many of you may want to do OCR, so optical character recognition, which means you want to look for text. If you do object detection with Amazon Rekognition, you can find a way to understand if there is text in your image, but it will not return any actual text. Okay, this is not supported yet. It might be. I'm looking forward to it. Another interesting feature that is not supported yet is a specific content detection, such as violence or nudity or other types of particular content that application may want to be very aware of. So you want to detect if there is any violence or nudity. Imagine if you are a social network or any other social application that does not accept such content, and you want an automated way to detect it as soon as possible and to delete it or even just not accept it. This is not supported. In a way, you could do it with object and labels detection, although I haven't really played with it that much to tell you if you can actually do violence detection. You probably can't. Another thing is logo, or let's say landmarks detection. So if you want to be able to detect logos or famous people or famous, I don't know, monuments, well, you cannot do that yet. Another interesting thing that will be useful is the actual rendering of all the detections that the API returns. So when the API returns a face or a set of labels or a set of different faces connected to each other, you will not actually get a rendered image with that information, as you probably imagined. You only get a JSON representation of such data. So the location of the faces and the set of labels and their confidence. You will not get a rendered image, as we will see, though, during the example. So all these examples that we will see will render this data onto the image, but this is not done by the API. This must be done by the API consumer. So we will see how you can do that too. So what about object and scene detection? Here I just took a screenshot of the AWS console. First of all, the API is completely stateless, meaning that every time you upload an image and you ask for object detection, the API will run over your image without any sort of caching, and they will not store the image, they will not store the binding between those pixels or that image and the result. So it's completely stateless. And what you see here is the AWS console that implemented a very useful and brilliant demo so that you can upload images and get a very user-friendly representation of the output. So as you can see here, I uploaded an image, and well, we get labels such as people, person, human, basketball. That's probably the most relevant label. As I mentioned, we cannot detect famous or important people. So this is Michael Jordan, and well, we cannot recognize him directly here. Another interesting thing that maybe you're not considering is that every API that we will see is rotation invariant. What does it mean? Well, if I rotate the image, I will get more or less the same labels. So I will get basketball, human, person, people, sport. Some of the detected labels will have different confidence score, but still, it's quite useful so that you may want to use to upload pictures taken with a smartphone, and you don't really need to care if if the picture was taken in landscape mode, or you don't care too much about the rotation. You will get still a relevant set of labels out of the image, no matter what the rotation. Same if I just rotate the image 180 degrees, it will give me exactly the same labels. This is quite interesting. What about facial analysis? Here I want to distinguish what's the difference between face detection and face recognition, because they are actually two independent features of Amazon Rekognition. So you can do face detection, meaning that you upload a picture and the system will scan the image and look for faces. So the result of the API will be the location and the landmarks and let's say the features of the detected faces. So this is all about detecting if there is any face, where is it, and more or less how confident you are with the detection and how confident you are with the features that you extracted. On the other hand, face recognition is a very different field. So you always start, of course, with face detection, but once you have detected that there are some faces, you also want to recognize them. You want to be able to compare two detected faces, and that's all about recognizing someone is about comparing them with some kind of representation that you have in memory, in your mind, or in a database, in our case. So what you want to do, or what Amazon Rekognition does actually, is to have some sort of numerical representation or vector representation of each face, and so that they can perform a comparison. And here the confidence is given by how similar such faces are. So let's say that face detection is needed for face recognition. It's like the first step, right? So this is a clear distinction, and we actually have two independent features. Two independent APIs on Amazon Rekognition, one for face detection and one for face comparison and face search. So let's say face search involves also recognition, provided that you have an index or a collection of faces. We will see that later. So let's see a quick example. Here I used the very same image, and one face was detected. So it looks like a face. Sounds good. It's a male. It's not really smiling. Well, it's not really confident about it. It appears to be happy, but still not too confident. No glasses, no sunglasses. This is fair. So the image is not super high quality, and the face is not a big portion of the image. Here you can see a little thumbnail of just the face that was detected, but it's a pretty good result. Again, if I rotate the image, also face detection is rotation invariant. So this is very interesting for the very same reasons. You don't really need to care how your image is oriented. You just upload it. If there is a face, it will be detected, even 180 degrees, so even a complete rotation or mirroring. Again, some of the features, if you check, like the smiling or the emotion, the happiness, is detected with a different confidence level. As you can imagine, it depends on the pattern that is found in the image, but still, it's not too different if you compare the results. I don't know why in this second case it is quite confident that Michael is not smiling. Well, this is quite subjective. It's not smiling. Of course, you can detect multiple faces. Even I think the maximum is 15 per image, for at least now. And in this example, 6 different independent faces were detected. And even though the resolution was not too high, but still it was high enough to find all 6 faces. And what's interesting here, well, the guy seems to be happy, right? Appears to be happy, and he's wearing eyeglasses but not sunglasses, so it is quite accurate, and you would have the same pretty good results for the other faces too. So as far as performance, I noticed that the speed, or let's say the response time, is proportional to the number of faces and not really to the size of your image. So I would assume that once a face is detected, the actual algorithm to find the landmarks and the emotions and so on takes more time than the image scan itself. So if you upload the same image with the same number of faces, you would get more or less the same response time, roughly. So this image with 6 faces will take longer to process than such an image with only 1 face. It also recognizes illustrations. This is, of course, a painting or an illustration of a human face, and it is quite accurate as well. So this is a female. It is not smiling. appears to be calm, no glasses, no sunglasses. So it is quite accurate. So what if we have an application and you want to make sure that only human pictures are uploaded? Well, you will need to first do object or scene detection, in which case, for such an image, you would see that one of the most relevant labels was like painting or illustration. So it's still ambiguous because it might be an image where there is a person holding a painting or holding some kind of drawing, but it's actually a drawing of a face. So it is still quite ambiguous and it's not easy to detect, but the API also works with such faces, not real, but still human. It's all about pattern, and here the pattern is clear. Only a human brain can actually recognize that this is not a real person, it's just a drawing. Maybe the hope is that the API will get better at recognizing faces, and maybe one of the feature will be, is it a real face, is it a real person, or maybe it's a drawing. It might be able in the future to detect such cases. The second case, the second API that you can use for face analysis is the one that allows you to do face comparison. So how does it work? Well, you provide two different images here. So one is a reference or a source image, and the second one is the target image. So what will happen is that the most likely or the most relevant face is taken from the source image, and it will be compared with each face detected in the second or target image. So here 5 faces were detected. Here I show only 3, but actually if I scrolled, there were 5 faces detected, and they were already sorted by similarity. So the API will return a similarity score for each face detected in the target image. Let's say that in general, even if there are more than one face in the target image, you may want to just check the first one, and if the similarity is higher than, say, 70 or 80 or 90%, well, you can say that that person is in the second image. The assumption is that it's pretty hard that the same person is twice in the same image. I can think of twins or other like composed images of more than one image, but I mean it really depends on your use case. Anyways, independently on the fact that the first face is or not in the second image, you will get one record for each detected face in the second image with a similarity score. So you can basically do whatever you want with such data. More or less, if a similarity is below 80, 85, it's probably not the same person. So even with such a low image quality, the system was able to detect a 96% similarity with the 2 Michael Jordan faces. This is pretty good. I like this quote. So it works most of the time. There are some cases where when it doesn't work, or where there are some problems that you need to be aware of. Let's say there are some limitations. I want to show you also some cases, some edge cases that you want to be aware of. So this is very simple. So there is only one face. Even a human would say, I can see only one face in this image, so it is quite accurate. What is not accurate are the features and the landmarks. So if you look close enough, you would see that there are 5 points for each face. It is the basic landmarks extraction. So 2 for the eyes, 1 for the nose, and 2 for the mouth. So if you see here, the 2 points of the mouth are not really aligned with the mouth, because there is some kind of obstacle, some kind of distraction as far as pattern recognition, and therefore you may experience some kind of strange emotional detection, like this guy is totally not smiling, and well, if you look closely, it doesn't really appear to be happy. It is quite subjective. I would say he's not happy right now. Well, just looking at the face, of course, the whole scene doesn't, it's even more clear, but even just by the face, the guy is not happy right now. And you can see that it really just depends on the two mouth landmarks that were detected. It was not the actual mouth, it was this kind of obstacle here. So this is one very simple case. The API itself is accurate, but the advanced emotional analysis might not be. What about other type of errors? Well, officially the API is not supposed to work with animals in general. Well, you can detect a cat or a dog or many other animals with the object detection. So you will see as labeled things like cat or dog or mammal or stuff like that, same as human. But if you run the facial analysis on a dog or a cat, you will not detect any face. But I noticed that it actually kind of works with primates and apes. So this is quite interesting, and it is also a little bit funny because, I mean, it appears to be female 100%. This is kind of strange. It appears to be smiling and surprised with eyeglasses. I mean, if you check what is actually detected on the face, well, the eyes are fine. As if you remember, there is 1 dot here for the nose and 2 for the mouth. So what happened here is that the nose was detected as a mouth instead. And well, it looks like a happy mouth if you kind of do the effort of imagining this like mouth. So it appears to be smiling, it appears to be surprised because it's probably an open mouth. And the eyeglasses are also, depending on the color, probably dark areas around the eye was detected as glasses. So this is kind of tricky. And again, if you want to detect that it's actually a gorilla, you may want to run object detection first. It's quite intuitive, and you will get, it's intuitive, it might be ambiguous, again, because you never know if it's a gorilla with a human face next to it or if it's actually the face of a gorilla. But depending on the use case, it might be more or less tricky. Same happened here. It's a very cute chimpanzee, and well, these look more like a male, not smiling, confused, but no glasses. Strange. Again, the mouth is not really detected well, and I mean, you can see the rest, but still, it's a face. Who would say that this is not a face? I would say it's a pretty face. And then there are other cases like this one, where I expected to find 1, 2, 3, 4, 5, 6 faces, but I actually found 7. For some reason, this area looks like a face, 93%. And it's a female, totally a female, 100%. So I don't know, I really can't tell you what happened here. If you look closely to just this area, I really cannot tell what happened. I guess it's just a strange pattern that as humans we cannot see, but for a machine it looks like a face. And it's wearing eyeglasses. So it's kind of funny to think. I mean, as a data scientist, I find it interesting. I would like to go deeper if I were Amazon and see what happened here and why such a little image becomes a face. Again, the hope here is that the system will get smarter over time and that you will get better results So it will be totally transparent, and the system will just evolve. We are talking about deep learning, so such models will be updated over time, and you will get automatically just better results. So here, I would like to share with you, this is just a gist. So GitHub, quick bunch of code is right here, okay. And I created one file for each case, so labels, faces, detection, comparison, and then indexing and search that I will discuss briefly in a few seconds. And so with such snippets, you can, everything is in Python, and you can easily use such functions to run your own image analysis stuff. So I also, for each case, I also coded a few lines to print out the actual API result. So for label detection, I'm printing out the labels with their confidence, and for face detection, it's a bit like 10 lines of code. I'm printing out, the emotions and the quality measures like sharpness and brightness of the face, and all the other features like eyeglasses and gender, like male or female, if there is a beard, mustache, if the mouth is open, and stuff like that. And then for face comparison, you basically just fill in the source and the target and the bucket you're taking your images from, and I will print the similarity metric, the similarity score. Okay, what about indexing of faces? Because in some scenarios you want to look or search faces in some sort of collection or database. So let's see what it means in a few more seconds. I wanted to show you what the API looks like and what a face looks like as far as API is concerned. So what kind of structure is returned? Well, for each face detected with the basic landmarks detection, you will get a bounding box, which is basically the XY position and the coordinates of the box that contains your face. And then you will get a few points, again, X and Y coordinates of the landmarks. So in the basic version, you only get 5 points, 2 for the eyes, 2 for the mouth, and 1 for the nose. That's basically the center of the face. And then you will get more data about the pose, so how the face is positioned with respect to the X, Y, and Z axis, and then other qualities like sharpness and brightness, and always a confidence score between 0 and 100, of course. But then you can also call the face detection API with, let's say you can get more data. If you specify attributes equals all, you will get every possible feature about each face. So for example, instead of 5, you will get 25 points. So many more points for the nose, many more points for each eye, and so on. You will also have emotional analysis. So you will say this face is sad or disgusted or happy or calm, and emotions like that. And then you will get a whole bunch of other, let's say, general features like, is the face wearing eyeglasses? Okay, no, 99.9% confidence. And for each of these features, you will get a value, a Boolean value, true or false, and a confidence measure. That's it. So I also think that more features like these will be added over time, as I mentioned previously. Okay, what about indexing and search? What happens is that you can create collections of faces. So let's imagine this box here as a collection. You can just give it a name or an ID. And then you can add new faces to the collection by calling the index faces API. So whenever I call such an API, faces are looked for inside the image, and if they are detected, they will be added to the collection. So each face will correspond to an ID, more or less shaped like this. So a very long, unique ID. What happens then is that another user, eventually with two different permissions, another user will be able to search. So I will give you a face either in the form of an ID or in the form of an image, and the API, so the face search API, will tell me if such face is contained in the collection or not. An interesting detail is that when you index faces, when you index a new image, let's say, you can specify an image, a custom image ID, which will be returned by the face search API. So I can say, look for this face, and the API will return me a list of matching faces and also where that face was detected. So the image ID of that face that was originally indexed. So you can build interesting applications with that. So this is the representation of an image inside a collection, and you will see a face ID automatically generated by the API, an image ID generated again by Amazon Rekognition. And this is the interesting part, the external image ID, which if you don't provide it, it will be generated, but you can provide it, and you can build some sort of reverse index here with your own image. Why is that needed? Because the Rekognition API never ever stores your images. So they only store, if you build a collection of faces, they will only store this kind of face representation. So it's an ID, an image ID, and external image ID, together with how confident they are with the face detection and where the face was detected in the original image, so the bounding box. This is everything that will be stored. When you call the face detection, face comparison, or object detection APIs, nothing will be stored. As I mentioned previously, those APIs are completely stateless. And this is how you would implement indexing. So on the left side here, this is a simple Python code for face indexing. So I call recognition.index faces. I tell you which collection I want to add my face to, and I tell you what's the name or the ID of my image. Here I was simply using the S3 key name, so just my image.jpg. And then I tell you where is the image. So it's my image.jpg inside my bucket. And let's say that two faces are detected in this image. So my collection will contain two faces, not one image. It will contain two faces. And what I can do next is that I can extract one of those two faces from my image. I can call it search.jpg, and then I can call search faces by image in the webinar faces collection. And the API will tell me that one face was found in my image.jpg and will give me the ID of that face. So we're not talking about person identification. Let's say that each face has a different ID, even if it's the same person. But if you search, if you call the search API with an image that was never ever indexed, you will still get a match if there are similar faces in the collection. So these can be actually implemented, can actually be used to implement some kind of, authentication, face-based authentication, if you want. So what about like sample architectures that you can implement? Let's say that you want to label or extract objects or labels from each image uploaded on S3. Well, what happens? A user will upload an image on S3. You can bind, you can configure an AWS Lambda trigger to such a bucket. And inside the AWS Lambda function, you can call Rekognition, index that face, and once you have indexed or or detected objects or detected faces whatsoever from that image, you can update some kind of database, for example, DynamoDB. Or eventually, if it's a search application, you can update or commit a new item in your cloud search service inside Amazon. So this is a way to automate the whole process. So you don't need to run Rekognition in the client or in your mobile application or web application. You can do everything behind the hood and connect everything with AWS Lambda, for example. Another possible scenario is that maybe you want, this is kind of strange, but maybe you want to authenticate some kind of service based on a picture. Okay, what happens? Well, you may want to call an API gateway resource by providing an image. Now you can do binary input and output for API gateway. So you can actually pass an image as an authentication token if you want. And then you can configure an AWS Lambda authorizer that will fetch such image and search it into Amazon Rekognition collection. And if the face is detected and if the face is bound to, I don't know, for example, a DynamoDB object, and if that user is authenticated to invoke such an API, you will be able to authenticate the API and proceed. Otherwise, you can just deny the API call. So this is an interesting scenario, and there are many, many more. Okay, I am done with today's webinar, and eventually I am available to answer to your questions. Let's see if we have any. Okay, first question, and how would you compare Amazon Rekognition with Google Vision API? So this is an interesting question. It is kind of tough because they cannot do the same things. So Google can do OCR, Google can do landmark detection. You can compare the label detection. You can compare the face recognition. The face detection, because Google doesn't actually do face recognition or face comparison. So as far as label detection and face detection, I haven't run any benchmark yet. I would say they are probably based on the same deep learning technology. Of course, they have different data sets. I would assume that, let's say Google is more, let's say maybe they have a more generalistic data set. So they already have a lot of images indexed, and they already have a knowledge graph that they can bound the extracted labels to, while Amazon is probably more focused on end user applications, so they probably built a different data set with a different goal. This is just my opinion. I cannot confirm anything. I don't know anything. Nobody knows anything about it. I haven't tested the performance yet, but I am working on it. And if you have any other specific question about the comparison between those two services, I'm more than happy to run tests for you, or to share my results. I think I will publish a new article in 1 or 2 weeks, so wait for it if you're curious. So apparently we don't have any other question. I hope you learned something new today. You will receive the link to our YouTube video if you want to rewatch it or to share this video. And if you have any other question or problem with API, feel free to reach out to me on Twitter, or eventually you can visit our Cloud Academy community and just ask questions and share your opinion. Okay, thank you everyone for attending. I really hope you learned something new today. Enjoy.